everybody. Today we will continue with part 4 of our smart monitor board presentation. And after showing you all the basic functions and how to program the real-time clock and how to use and read the values from the power monitor, I really think that it's time to go for, let's say, a real world example. Yeah. So for today, I just prepared the setup that it's let's say doing some real world measurements, and we will be able to see the data. Hopefully we will be able to see the data uploading on Thingspeak. I had lately some Wi-Fi issues, but I really hope that all the internet connection problems were solved. Yeah, so what do we have for our setup for today? Um, we have our next evolution board, the ESP8266 board. It's connected through the USB cable to the computer USB port because we will use it for programming, and after that for seeing also the data and the status of the connections and reports. We have our new smart monitor version 2.7 extended version connected directly through the I2C bus. And now on the input, I have 12 volt variable power supply connected. Yeah, so this is the plus, this is the ground, the minus. Yeah, so it's about 12 volt. It's a variable power supply. We will vary the voltage and we will see what's happening in terms of power consumption and also how accurate the data is read it. As a load, this time we will use a light bulb. It's actually a standard filament light bulb from the car. Yeah, it's looking something like this. Yeah, this one it's 12 volt 21 watt light bulb. Yeah, I'm using this filament light bulb because as you know, in case of standard filament light bulbs, you have you don't have a stable power consumption. The resistance of the filament will vary with the temperature, will vary with the heating of the light bulb, and this will look actually very nice on the data upload graph, where we can see a lot of slightly variation in the voltage dropout, in the current used, and obviously also in the power consumption. Yeah. Okay, so let's let's go a little bit further, and let's switch on the main software window and see what we need to do to be able to achieve our goals for today. Yeah. Okay, so now in terms of the software, it's one thing that I really want to show you and explain a little bit. We have just done a very simple init Lua initialization file, so you will be able to easy configure your Wi-Fi network, and you will be able to upload the data on Thingspeak. Yeah? So basically what we have here, we have all the files from our previous related examples. Yeah, so we have the scan bus, you know for what it's used. We have the real-time clock, software, and we have also the smart monitor Thingspeak program. Yeah. And on top of all of this, we have the initialized file, the init.lua file. Yeah. So basically, when you are connecting the device for the first time, it will run at power up the init.lua file. Yeah. So it will look something like this. Yeah. So if you are pressing restart ESP, you can see it will say connecting to Wi-Fi, and it will try to connect for about 12 seconds. Yeah. If it won't be able to connect, then it will say connection failed and will ask you to check your network configuration. Yeah. So on the left side, you can see the listing of the init.lua file. Yeah. So basically, what you need to do is you need to add your Wi-Fi SSID. In our case here, for our example, because we are in the ESP lab, it's ESP lab 1, and also the password. The password of today for this example is exactly like you can see it there. Of course, you need to bring here your own Wi-Fi SSID and your own password. Yeah. So if we will just save it as it is, it should be able to connect. Yeah. So let me try to save it on the ESP, and now it will start trying to connect to the Wi-Fi, and as you can see, when the connection is okay, it will say Wi-Fi connected okay. It will show you the allocated IP address through DHCP, and will start the smart monitor. Yeah. Now the voltage is nothing. We have the error because it's no voltage applied, no power, no current, no energy, obviously. Yeah. Okay. So this is how it's looking the configuration. Now we can say that everything is okay and the Wi-Fi is properly configured. Okay. Now on the Thingspeak side, we need to set up a proper channel for our data upload. Yeah. This is a channel that I have set it up for reading the data from the smart monitor. Yeah. So we have a graph for the voltage, and you can see already it was sent data to Thingspeak. You see, sending data to Thingspeak. Yeah. So as you can see, we have this 0 voltage and no current and no energy and no power and so on. Yeah. Okay. So the previous data was just sent back. So okay, back. We have a graph for voltage, one for the current, one for power, and of course one for energy. That it's, if you want, some sort of energy counter. So basically we can see the total energy consumption for the device in a certain period of time. Yeah. Okay, so that's it. Let's go a little bit back on the main. Yeah, so you will be able to see here how data is uploaded. Yeah, so we have still 002, nothing. Yeah. I will connect also the load now, and probably we will see soon the data coming also on the Thingspeak. So we will start seeing data here, and also it will be properly reported in the upload window on the right side. Yeah. So let's give it a little bit of time. And now we have new data. As you can see, voltage is 8.196 volt, current is 1.4 amps, total power, instantaneous power consumption is 12.18 watts, and energy consumption so far it's obviously 0.2 watt per hour. Okay, and in the Thingspeak window we can see the new data uploaded, the new voltage 8 volt, the new current, the energy will start counting, and also the instantaneous power 12 watt. Yeah, so this light bulb was giving us from the initial 12 volt about 4 volt dropout voltage. Yeah, okay, so now let's try to increase slowly the the voltage from the power supply and see what's happening in terms of recorded data on the corresponding graphs. Yeah, okay, so we will see also the variation uh, related with the light bulb. As soon as it will become warmer, the resistance is changing, and things will change a bit. Yeah, actually, before changing, look at here. Yeah, so it was 8.196 volt and 1.4 amps. Yeah, and after that the dropout voltage has decreased a bit at, and we have 8.232 volt and 1.396 amps, and after that we have 8.636 volt. Yeah, so the dropout voltage has dropped again, and the current of course has dropped also a bit. Yeah, so what's happening, the light bulb is becoming a little bit warmer. As you can see, the energy counter, it's counting. Yeah, 0.2 watt hour, 0.4 watt hour, 0.6 watt hour, and so on. Yeah, so this is how data is changing. Just a bit, might be a good idea maybe to clear a little bit the channel to be able to see uh, to better see the data. Yeah, the previous data was giving us a little bit of, okay, now I think it's better. Now I think it looks even better. Yeah, so we have 8.208 volt. Yeah, this is the last uploaded value. Yeah, 8.208, 1.404, 1.404, power 1196, and energy consumption 0.79. As I said, it's normal. This is the energy counter if you want in watt hour. Yeah, I'm still insisting because probably if you have seen my previous videos related with the power monitor, this was an entire afternoon story. Okay, um, okay, so data it's uploading. Okay, uh, we should have soon here another dot. You can see it. Yeah, so another pair of data was uploaded. Now let me increase uh, a little bit the the voltage on the power supply. uh, I want to check what we can check now. It's that at precisely 12 volt the light bulb will be around 21 watt power consumption if they were right on the on the blister, on the back of the blister. You remember it was right that it's 12 volt 21 watt light bulb. Yeah, okay, so I will increase it now to about 10 volt. We should be able to see it soon. Let's see what we have here. 9.664 power, it's already around 13 watt. The current it's increasing, and obviously also energy consumption it's increasing. Yeah, it's not linear because we just increased a bit. Okay, so I'm still waiting to see another pack of data uploading, and after that I will go straight to 12 volt, and we will see what's happening then. Another thing maybe that will be good to know about. Yeah, you see now we have the 10 volt. Yeah, so 10.128 volts, current 1443, power 196, energy consumption. Yeah, so basically this is the 10 volt voltage. Yeah, let me go to 12. Just a sec. Oops, this is about 12 volt. Well, let's see what's happening. I'm very curious. They said that it's 21 watt cold or hot. Probably hot. I don't know. Okay, so data was uploading. Yeah, we have new values, 11.71 volts, 1.71 amps, and almost 20 watt. So if I go a little bit closer to 12 volt, little bit closer, just a little bit, just a little bit. Okay, so as you can see, it's 11.8 volt. Oops, this is my, okay, so 11.6.76 volt, 11.8 volt. The current it's 1.6 amps, and we have a power around 21 watt. Yeah, so what is telling us is that yes, the the values that we had on the, if you remember, yeah, uh, on the blister package of the light bulb, yeah, 12 volt, 21 watt, it's correct. Yeah, so this light bulb has about 21 watt. Yeah, this is the power consumption. Yeah, so now it's hot, it's becoming hotter and hotter. Yeah, and of course the voltage, the resistance is changing, and the voltage dropout it's lowering. Yeah, so it's around 90.34 watt, so basically around 20 watt. Yeah, this is the graph. We can see exactly what we have done. Yeah, so we have started around 8.2 volt, and after that we increased to about 9 and 10, and we went to 11, and after that we went over 12 volt. Yeah, so basically now we are around. I'm looking on the main power supply voltage meter. We are around 12.75 volt. Yeah. Okay, so that's it. That's it for today. Um, you have seen how to set up the smart monitor board, and also how it's looking the data upload on Thingspeak. Thank you very much for watching, and if you like my videos, then please give me a big thumbs up, and see you next time.